Hello students, today we'll see
Exercise 1.1, question number 13. Given the matrix A, B and C, find a matrix X such that A, X, B equal to C. So it is given A, matrix A into matrix X into matrix B is equal to matrix C. So I have to eliminate this matrix A and I have to eliminate the matrix B to get the matrix X here. Always the unknown will be kept on the left side, isn't it? Suppose if I have 2x is equal to 8, what will I do? I take this 2 that side. That means I divide by 2 the inverse on both the sides. So same thing I am doing it here. So I wanted this matrix X on the left side and I have to take matrix A and B to the right side. So for that I have to eliminate, so that I have to multiply by the A inverse to eliminate this matrix A. So I'm going to pre-multiply, because A is here, I cannot multiply this side. So A inverse into A, because I have a matrix X here, X, and B I have to post multiply. Okay, matrix B is on the right side. So I'm going to post multiply is equal to the same thing I should do this side. For A inverse I pre-multiplied and B inverse I post multiplied. So you should know the concept of pre-multiplication, post multiplication. If you have two equal matrices A and B, pre-multiplication means multiply before A and before B. That is CA is equal to CB. Post multiplication means after A and after B. So AC is equal to BC. That is called post multiplication by a matrix C. So I multiplied by matrix C like this. AC is equal to BC. That is called post multiplication. The reason is, what is the difference here? Actually CB and BC may not be equal. In matrix, you know that in matrices, the multiplication of matrices is not always commutative. Matrix multiplication is not always. Rare cases they will be commutative. So we cannot say that whether CB is equal to BC. So these two are, they need not be equal. CB and BC need not be equal. So here we are multiplying A inverse. So left side, that is pre-multiply. Same way I have to pre-multiply here. I cannot multiply A inverse on the right side, then it will be wrong. Similarly, I have post multiplied by B inverse. I have to post multiply this side. So you already know that A inverse into matrix A will give you the identity matrix. Similarly, B into B inverse will give you the identity. So this will become now I into X into, this is also I, is equal to B into B inverse is also I, is equal to A inverse C into B inverse. So I X, this is X matrix, this is not into, I X into I. You are multiplying a matrix X by I. That means you get back matrix X, the original matrix X, is equal to A inverse C B inverse. So we need the matrix A inverse. We know only A. So A matrix is given. Let us write this as equation 1. Let us find A inverse, that is 1 by determinant of A into adjoint of A. That is 1 by determinant of A is multiply 1 into 0, 0, minus of minus 2, that is plus 2. Adjoint of A is, interchange these two numbers 0, 1, change the sign here. This will become, adjoint of A will become 0, 1, minus 2, 1. Okay, 0 and 1, minus 1 will become plus 1 and plus 2 will become minus 2. Similarly, we have to find inverse, B inverse. What is B inverse? 1 by determinant of B into adjoint of B. So it is equal to 1 by determinant of B is 3 minus of minus 2, that is plus 5. So that is 1 by 5 adjoint of B. Adjoint of B is interchange these two numbers, 1 here and 3 here, change the sign, plus 2 and this is minus 1. So adjoint of B is 1, 2, minus 1, 3. You can just see once again, 1 because I interchanged 1, minus 2 will become plus 2, 1 will become minus 1 and 3 will come here. Now we have to find the product of these three matrices. So substitute all this in equation 1. X is equal to A inverse. You can take out the scalars outside. A inverse you have 1 by 2. B inverse there is one scalar 1 by 5. Then what is the first matrix? A inverse. So write the matrix A inverse 0, 1, minus 2, 1. This is the matrix A inverse. Then matrix C. C is 1, 1, 2, 2. Matrix C is 1, 1, 2, 2. Then matrix B inverse is 1. The scalar I have taken it out. So it is 1, 1, 2, minus 1, 3. So now I have to multiply this. You can multiply in any order. You can multiply these two and then multiply this because matrix multiplication is associative. Matrix multiplication is associative, not commutative. Okay, multiplication is associative. So I can multiply these two. So x is equal to 1 by 10. Multiply these two. I am multiplying 0 into 1, 0 plus 1, that is plus 1 into 2, that is 2. Then 0 and this 0 again 2. A1 2, 2 1, minus 2 plus 2 0, minus 2 plus 2 0. There is a first matrix into the matrix 1, 2, minus 1, 3. That will give you 1 by 10. 1 by 10, multiply again, 2 into 2, 2, minus 2, 0. 2 into 2, 4 plus 6 is 10. 0 minus 0. 0 into 2, that is also 0. So the matrix is, so multiply now every element by 10. You have 1 by 10 outside. So this will become now 0. This is 1 by 10 outside. 0, 1, 0, 0. So the matrix X is equal to 0, 1, 0, 0.